Alright, this video will be about chapter 3, and we'll look at some of those practice problems from 3.2. Let's see. I think they're going to get into some empirical rule, and there's not much documentation on this. So let's just get there. I think it starts around question 11. Let's make sure. Well, this is just pretty straightforward. They give you the data. You can open it in StatCrunch or wherever you want to open it in Excel and import it into something else. But that's not it. Let's move to 12. All right, this is where we're going to be using the empirical rule. So we have to go over the empirical rule. Now, later on in the course in chapter 6, we're going to do a method that supersedes the empirical rule. And we'll be able to not only approximate what we think it is, but we'll know the exact amount. The empirical rule is an approximation. It says scores of an IQ test have a bell-shaped distribution with a mean of 100 and standard deviation of 18. Use the empirical rule to determine the following. What percentage of people has a score IQ between 82 and 118, less than 82 and 118, and what percentage of people have an IQ greater than 154? Well, again, in order to solve this, you first have to realize, let's pull up our chart here, and we're going to kind of talk a little bit about the empirical rule. If we have that normal bell-shaped curve, the empirical rule basically states that 68% of the data will be within one standard deviation of the mean. So in our case, the mean was 100, and the standard deviation was 18 points. So let's go one deviation out. That's 118. And if we go one deviation below 100, that puts us at 82. So empirical rule states this nice blue color represents 68% of all the data. And then it also goes further and it says, well, if you go out 2 deviations from the mean, so I'm going to add another 18 to get 136, and I'm going to subtract 18 from 82. I think that puts us at, I want to say 64. Yeah, 64, I want to say. Again, if we add 18, we get that. So, and here we know that between 2 deviations of the mean is 95% of all possible data. And then there's even another step. That's the third step. And if you go out 3 deviations above the mean, so we're going to add 18 to 136. That's going to put us at 154. And if we subtract 18 from this guy, that's going to put us at, I want to say, maybe 46. And we'll give it another color. And so apparently, if you go out 3 deviations, that's 99.7% of all the data. So that's kind of how it works. So since the inner portion is 68%, each little sector is 34. So this is 34, 34. And then the next is 95, and the difference between 95 and 68 is 27. So half of 27 is about 13%. So 13% in this little sector and another 13% here, so on and so forth. And so that's how you would do it. If you go online, there are tons of empirical rules, charts available. If you were to Google empirical rule, and look at all the different charts. But now we can answer the questions pretty easily. It says, what percentage of people has an IQ score between 82 and 118? Well, between 82 and 118, that's going to be 68%. So that's based on empirical rules straight away. What percentage of IQs is of less than 82 or greater than 118? So since 68% is between, the whole thing is 100%. So what we would have to do is subtract 68 from that 100. And we'll actually get 32% remaining. So you can just say 32% therefore will be the other portions. And then what percentage of people has an IQ score greater than 154? Well, greater than 154, that means you've exceeded you've exceeded 3 deviations already. So again, that is an awful lot, an awful lot. Like these two portions, more than 154 and less than 46 accounts for 0.3%. And so we're saying half of that even, because we include this piece. So in other words, 0.15% will be greater than 154. We'll have an IQ of 154, 0.15%. Now, we have to subtract this from 100 to get the exact percentile. So we're basically going to subtract 15% from that 100%. .855%, probably can round it to 99.9. Here's the empirical rule. 3 deviations is 99.7. And the question was, what percentage of people has an IQ score? Oh, okay, yeah. No, well, yeah, 99% of all people will have an IQ of that? No. More like 0.15% of people will have an IQ of this. Yes. So that was the how much in this portion. So we didn't have to subtract it from 100. The question was how much in this proportion, was not the percentile. I gotta be careful there. Let's look at the next question. Okay, so again, it says a certain standardized test math score has a bell-shaped distribution with a mean of 515, standard deviation of 105. What would be this percentage? Well, that's if you subtract 105 and add 105, that's 68%. What percent between greater? Well, that would be 32. And then what percent of standardized test scores is greater than 725? Well, that's already 2 deviations above, we believe. So then the question becomes, after 2 deviations, is 95%? 2.5, then we could just say, well, 2.5. All right. So that's going to do it in terms of the review of the empirical rule. Hopefully this was helpful, and let me know if you have additional questions.